All right, this is your Unit 10 circle review, the one for extra credit, so you might want to pay attention throughout the duration of this tutorial. Most likely because of all the problems, they'll be broken into two parts, so please bear with me. The first section asks for you to identify the following parts of Circle J. The first part is line ED, which is right here. Since line ED is touching touching the circle in two places, line ED is a secant. The next one is segment JC, which is this segment here. Since segment JC starts at the center, which is J, and touches the edge of the circle, it is thus a radius. Angle BJC BJC. Since angle BJC has a vertex that is point J, which is the center of the circle, then angle BJC is a central angle. Arc CD is next. Arc CD is this arc right here. And since arc CD is definitely not covering half of the circle, and it doesn't appear to be even larger than half of the circle, so arc CD is a minor arc. Next up is arc BDE. Start at B, go to D, and then to E. Since arc BDE is formed by the line BE, which is your diameter, then that means arc BDE is a semicircle. Half of the circle. Segment FB is this segment here. Since both endpoints of the segment touch the circle, it is considered a chord. Next up is line AB, which is this line out here. Line AB touches the circle only once at point B. So line AB is a tangent. Line BE, we already somewhat discussed. Since it goes through the center and goes edge to edge like a chord does, it is the diameter. And lastly, we're looking at arc F, D, oh, wrong direction, sorry. Arc F, D, E. Arc FDE would be a major arc. because it is more than 180 degrees. It is more than half the circle. Number 10 would like for us to find the area of the shaded region. To find the area of a sector, the formula is central angle divided by 360 times pi radius squared. So in this case, the central angle of our arc is 156 degrees. The radius of our circle is 4.8. So now we just grab our calculator and type it all in to get the result. So I would type 156 divided by 360 times pi 4.8 squared. So the area is approximately 31.37 centimeters squared. 31.37 centimeters squared. I believe that's what the calculator told us. Yes. Okay. Number 11 would like for us to find the length of arc CD. The formula for arc length is very similar to that of the area of a sector. For arc length, it's the central angle divided by 360 times the circumference of the circle, so 2 pi r. So for this arc CD, the central angle is 83 degrees times 2 times pi times the radius, which is 9 meters. So now again, we grab our calculator. Have 83 divided by 360 2 pi 9. And that's enough. So the arc length is about 13.04 meters. 13.04 meters. All right, number 12 would like for us to find the values of x and y. X is this arc here, and that arc is related to this angle right here, which is an inscribed angle. So since it's an inscribed angle, the measure of the arc is equal to 2 times the measure of the angle. So with that being said, x is equal to 2 times 24, which is 48 degrees. Now y is this angle here, which is associated with this arc, 121. So on this one, the measure of the angle is equal to the measure of the arc divided by 2. So that means y is equal to 121 divided by 2, which is 60.5. Should be 60.5. Let me double check. Yes. All right. And it's degrees. On number 13, they would like for us to find the measure of angle QRS. If I trace it, QRS, so it's this angle here, which is associated with arc QS. So I need to first find the measurement of arc QS, and then I would use one of the two formulas we just used in the previous problem. To find the measurement of arc QS, I know that there's two other arcs on this circle, and the grand total of measurement for an entire circle is 360 degrees. So if I take 360 minus 115 and 134, I would get the angle or the arc I need. So let's do that first. 360 minus 115 and 134. So it's 111. So this arc QS is 111 degrees. So now that I know that, I'm going to use the formula that says the measure of the angle is equal to the measure of the arc divided by 2. So our angle Q, oh, unlock the door. Unlock the door. Unlock. Is equal to 111 divided by 2, which should be 55.5, I believe. Yes. So 55.5 degrees. On to the back. Number 14 first wants us to find the measure of LUV. So this angle here. LUV is inside the circle. So since it's inside, the measure of the angle is equal to arc plus arc divided by 2. So that means the measure of angle LUV is equal to 88 plus 104 divided by 2. So grab our calculator and type this all in at once. So 88 plus 104 divided by 2. Notice I put the top part all in parentheses. You have to do it that way Or you can do it with alpha y equals, but I'd rather do it quickly and as few steps as possible. That's just my preference. So the angle measures 96 degrees. Alrighty. On number 15, it tells us that arc YU, this arc here, is 137. Arc XV is 39. We want to find the measure of this angle W, which is outside the circle. So, since it's outside the circle, that's the measure. The measure of the angle is equal to arc, big arc, minus arc divided by 2. So the measure of angle W is equal to 137 minus 39 divided by 2. Notice the difference from inside to outside. I use subtract instead of add when it's outside. So 137 minus 39. And it's always bigger minus smaller. And you get 49 degrees. Mm-hmm. Number 16 wants us to determine the value of x. On number 16, what you see are two chords intersecting in the circle. So the formula we're going to use is part times part equals part times part. So that would mean that this is a part, x, times this part, 4, is equivalent to this part, 6, times this part, 8. All right, so now that we know that, let's go ahead and multiply as we should. So that will give us 4x is equal to 48. Divide both sides by 4. And x is equal to 12. For number 17, we see two secants because they touch this circle twice. So since it's two secants, the formula is outside times whole equals outside times whole. So in other words, this is outside, and then the whole thing for this one would be y plus 5. Oops. And the whole thing here would be 7 plus 6, which is 13. So again, it's outside times whole. So outside is 5. Whole thing we said was y plus 5. The other one, the outside was 6 times the whole thing, which is 13. Now we have to distribute the 5 on the left side of the equation. So that would be 5y plus 25 is equal to 6 times 13. 8. So 78. Yes. Okay. So we subtract 25 on both sides. And when you subtract 25, you get 53. And divide both sides by 5. And y is equal to, this is not going to divide evenly. 10.6. 10.6. All right, on the next problem, it wants us to solve for x, and this one we see one tangent and one secant. So in this case, it's tangent squared equals to the outside of the secant times the whole secant. So the tangent in this case is x squared because it touches the circle once. That's what tangent means, touch the circle once. And the secant is this one because it touches twice. And the outside would be 300. The whole would be 9 plus 3, so 1200 or 12,000. So now x squared is equal to 300 times 12,000, which is 36 and 5 zeros. And now we must take the square root of both sides to get x by itself. And it's going to be 6. And I'm not 100% sure how many zeros. So let me double check. Square root. 3, 6, 1, 2, 3, 4, 5. Oh, I thought it was 6 something. I'm sorry. So it's approximately 1897.37. 1897.37. And last question, number 19. We got to solve for x. Now, we know that this angle and this angle are congruent, so this one is also 28. And we know the whole circle is 360. So we could take 360 minus 28 minus 28 minus 205, and we would get our answer for x, because x represents the angle. So that would lead us to $99. So x equals 99 degrees. And this concludes your tutorial. Good luck.